Okay, we're looking at the first set of notes for the functions section, and I'm going to call this F1 for functions number 1. Our goal for this video is to be able to use function notation to find values. And I want you to know, so the first thing we need to do is we need to know and understand A, what's a function, B, what is function notation, and C, how are we going to use that in order to find values. So first things first, what is a function? A function, it is a special type of relation, so it is a relationship with two or more variables. I'm going to say it like this, in which there is one output for each input. All right, so here we have exactly one output for exactly one input. So if you put one thing in, you better get one thing out. So we have one output for each input. Now, function notation, right? Function notation looks like this: f of x, right here. And this function notation, this is really going to be y. So you know we used y equals mx plus b to create a model for our starburst project. Well, now instead of y equals mx plus b, now we can say f of x equals mx plus b. And now let's see, what's my input variable? What am I going to be using as the input? The input here, that's x, right? So my input is x, and then my output is then going to be f of x. So whatever goes in is going to be x, and whatever comes out is going to be f of x. And now we get to pick numbers that go in for x. So let's take a look at an example here. Let's take a look at an example. Let's try, if I were to hand you, so y equals, let's say 3x minus 4. Right? In function notation, I'm going to replace that. It's really going to read f of x equals 3x minus 4. All right, so this is our first example here. Now, I get to choose numbers that go in for x. So I'm going to make a little chart here. I'm going to say this is x and this is f of x. And I get to put numbers in for x. I get to choose whatever I want. Here, let's see, I'm going to choose -2, I'm going to choose 0, and 2. So I'm going to take -2 and I'm going to replace all the x's with -2. So I'm going to plug -2 into the function. That means I'm going to now say f of -2 equals 3 times -2 minus 4. Notice that whatever I replace this x with, so in this instance I replace x with -2, I have to replace this x on the other side with -2. And notice that I put the -2 in parentheses. Everything else is going to stay the same, except for x. I have parentheses and I'm plugging in a -2. And now I can simplify this a little bit. 3 times -2, well, that's -6, and -6 minus 4. So -6 minus 4, -6 minus 4 equals -10. So on my chart over here, when x equals -2, f of x equals -10. And now with 0, so f of 0, I'm replacing x with 0. And we all know 3 times 0 is 0, right? And 0 minus 4 gives us negative 4. So for 0, I get negative 4. That's a 10, not a 16. I'm sure there's at least one of you. That's negative 16. You meant negative 10. Yeah, it's negative 10. And now for our last one, f of 2. f of 2 is 3 times 2 minus 4. And we know 3 times 2 is 6, and 6 minus 4 is 2. So when I plug a 2 in, I get a 2 that comes back out. So again, when I plug a 2 in, I get a 2 that comes back out. Now these pairs here, right? Remember, f of x is the same thing as y, right? So now we're looking at x and y values. These values, right? So let's say it like this. Let's say these values, we're talking about these ones over here, correspond to the x, y values on a graph. All right, so these are the values that are going to correspond to x, y values on a graph. So I wonder what in the world does this actually look like? So let's build a graph real quick and let's see. So I'm going to do that down here. Alright, so let's make a really quick graph. We know here we have the y-axis, here we have the x-axis, and I'm going to count little bits here. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 6, 7, 8, 9, 10. Oh, right here. 1, 2. Okay. All right, so we are graphing. So we're going to graph f of x equals 3x minus 4. And let's just plot these values here. So negative 2, negative 10. So negative 2 in the x, negative 10 in the y. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So negative 2, negative 10. It'll be about right there. Then we have 0, negative 4. So 0 in the x, negative 4 in the y. 1, 2, 3, 4. Here we are. 2 in the x and 2 in the y. So 2 in the x, 2 in the y here. And now I should be able to draw the line of that graph. It's going to look a little something like so. Put it right here. Hey, nice. Very good. That one showed up real well. Well, I was a little bit off, but at least it looks neat and it looks somewhat organized there. Okay? All right, so let's get back to the goal. All right? The goal of today, the goal of this video, is to be able to use function notation to find values. Now, let's go back through this process. I'm going to give you one more example. Let's take one more example. And let's try f of x, and let's try something like, I don't know. Let's try f of x equals, let's go with negative 2x plus 3. Alright, so f of x equals negative 2x plus 3, and let's make a little chart here. We have x, f of x, and when I plug in, let's go with negative 2, negative 1, 0, 1, and 2. Go ahead and pause the video now. Pause this video, plug these numbers in, and see if they got exactly what you were looking for. Alright, now I'm going to go ahead and plug these numbers in and see what we get. So f of negative 2 is negative 2 times negative 2 plus 3, which is 4 plus 3, and that is 7. F of negative 1, negative 2 times negative 1 plus 3, which is 2 plus 3, that's 5. F of 0 negative 2 times 0 plus 3, which is 0 plus 3, and that's 3. F of 1, negative 2 times 1 plus 3, which is negative 2 plus 3, which is 1. And F of 2, negative 2 times 2 plus 3, which is negative 4 plus 3, that's negative 1. So my values that correspond here are 7, 5, 3, 1, negative 1. Again, one thing to keep in mind. When you know the x values, we are going to plug and chug. Plug and chug. Take that number in, chug it through the system, and get this number out.